Hello everyone, welcome back to the part 4 of the React interview series. I hope you liked the previous parts and you have learned something new from this. So in part 4 is going to be exciting and going to be a little bit heavy in terms of the topic that we're going to discuss. We're going to discuss about app responsiveness. How can you make your React app responsive? Responsive doesn't mean that here that you will be making it work in different devices. Responsive means that your app will be responsive to user interaction, the smoothness, there is no sloppiness, right? So how do you make sure that you will take care of those things in your application? Also, we are going to talk about global storage in React. We are going to talk about the Redux concept in depth. So the questions today will deal with these two primary concepts. I hope that you like them. And as you like, the thing that I keep telling about practicing, please practice. Without practicing, the learning is not enough. Go ahead and practice. And if you have any questions at the end of this video, please put a comment in this. So without any further delay, let us get started. So use transition is another hook for that React.js provides out of the box. It's comparatively a new one in React 18. And when there is an interview happen, we as an interviewer want to know how much relevant you are to the language, whether what is the latest inclusion in the language. Also, it's use transition is something that I believe we should really know to save some performance issues in our code. So the intention is to know what do you think about expensive rendering in React? How did we use to manage it before, and how use transition actually solves some of this expensive rendering problem? Okay, so let's take a look. Again, we'll be going to see some application. We are going to see how things used to work before versus how things are working now. But first, let's understand the fundamental. What is expensive rendering? Let's go about it. So when there is an expensive rendering, it means there is a differentiation between what is called urgent versus non-urgent, the priority and the non-priority. What does it mean? It means that when React.js component change state, when its state changes, the components re-renders, right? If the state change happen at the same time, React is smart enough to batch those updates together, because it doesn't really want to re-render the component every time, right? It want to kind of combine the state changes as much as possible together, and then they render the things once, because all the state changes are happening almost at the same time. At a fraction of time it is happening, so it can batch and then do the update. Now, while doing that, you can think of a case like in one state change, it might be very simple, just like you are changing the text in the input text box. But another state change, which is occurring almost at the same time, that can be very expensive, like filtering a list of million users, right? Now, if React combine these two state changes together and render your component, you are actually waiting for a bigger state change, where the smaller state change could have been reflected in your application just outside of it, right? These two things could have handled in a different way, but React by default thinks every state change is of high priority, so it doesn't really differentiate. So till React 17, until React 18 we got, this was the case. But React 18 got a lot of stuff in terms of concurrency, and one of the best thing that we got is use transition hook. Using this hook, you can actually mark a state change as non-urgent, and you can tell React, hey React, this particular state change is non-urgent, so really don't hold your component rendering, don't hold your other state changes just because this is an expensive one. So you can take the call as a developer based on your use case, and you can do it. Now let's understand this with this demonstration. Okay, so let's assume that this is a component, and then we have multiple states. We have two states. The first state is something which is like changing the value of a text box, and second one is based on the value in the text box, you are filtering a massive user list. So this is the first state, and this is the second state. Now the state change happened. The state change, you see that there's a color change, means state change happened, and it happened together because it's almost happening at the same time. React is batching this state and is making the update, and once the state change happened, there is a re-rendering happening. You see the component got re-rendered. So this is a problem because the second state change is quite expensive, and we actually waited this component re-rendering to happen even though the first state change happened very fast. what would have been best is like to tell React that, hey React, the second state change for filtering through a massive list, that can actually wait. It's a non-urgent, but urgent thing is like the state change of the input text was filled, so that user won't feel anything unresponsive. Okay, so alternate solution that we have it today, again the same component, again both same state, and then now we are saying this state change is urgent, this state change is non-urgent, so we are marking it as non-urgent. The first state change happened, and then the component react, actually component re-render. Then the second state change happened, later point of time, and then the component re-render. So this is how things have changed, so that for your React application, is the component is really not waiting on something massive to happen for a simple and quick thing to take place, right? Now let's understand this with an example. So what we'll be doing exactly the same thing, like we'll have a text box, we have a user list, and we'll try to see like how it reacts without use transition and how use transition is going to solve this problem. Okay, so let's see that in code. Take a look at this code. So I have a kind of a very simple project where I have a fake user.js. What it's doing basically, it is using a library called faker and creating 10K user data basically with their name, avatar, and background. And in my app.jsx file, basically before that, the main.jsx file, I am passing these users from the fake user. And in the app.jsx file, what I'm doing, again, a simple thing, I have a text box and then I have a div to render all those users. And then there is a text box at the top where user can type a search term. And based on the search term, I am going to filter the list. I'm going to populate this filter list. Very simple thing. So for that, there are two states. One state is search term. Another step is the filtered data. What is search term? Search term is something that you are putting inside the input field. And based on the search term or the query, what I am going to do, I am going to filter the user data with this filtration. And then the filtered data I am setting into the, again, filtered state, and the same state is kind of working out. Now, think about the situation. Here, both the state changes are happening almost at the same time. Your handle change function that you actually call when somebody types something into the input box, you are changing the search term. You are also taking the things, right, the search term, basically the value to filter the list. Now, this is very quick, but this one might take time based on how many users you are dealing with. So the re-rendering of this particular component to have the fresh data, it might take longer time, but what you are actually stopping is the typing into the text box straight away. This might get sluggish because you are also filtering things at the same time, and your component also re-rendering based on the state changes. So this is the problem that we deal with now, or dealt with until React 18 came up with the use transition hook. Now let's see the same variation with use transition and try to understand that how things work for use transition. So I have this another version of the same app. I'm going to close this so that we don't get confused. So same thing, we have a fake user.js, we have a main.js, we're passing that user, and then open the app.jsx file. So here we are having something extra. We have something called use transition hook. The use transition hook returns two things. One is like is pending, and another is called start transition. Is pending is a Boolean value data type variable. By default, it is true, and as long as the start transition function executes. So start transition is a function which executes. As long as it executes, the is pending remains true. Once the execution is over, is pending become false. Okay. Start transition takes a callback as a parameter. This is the callback, is taken as an argument. And in this callback, you actually write what you want to mark as non-urgent state change. So if you see the code change over here compared to the last one, in the last one we had like set search term and set filter, just together, and the batch update was supposed to happen. Now I am telling React explicitly, hey React, just go ahead with the set search term as an urgent priority based state update. But when you actually get to set filter, please consider it as a non-urgent. Now React will take the call to take care of this one as soon as possible, render the component, won't wait for this one to happen. And once this is happening, this state change happening, later point of time, it will re-render it again, right? So this is what use transition is going to save us from. For a longer taking, operation or the state change, you can always put inside the start transition. Now, how are you going to use this is pending? I told that is pending, it will be remaining true as long as this execution happens. Once the execution is done, it will be false. So it means that with is pending, you can actually do something like loading. As long as is pending is true, it is loading, it means that that state change didn't happen, which is inside the start transition. The moment start transition execution is done, is pending become false. That means you have the latest data and then you have the latest JSX as well. So this is really, really great. Now let's see it in the application, the same application side by side, and try to see like what is the difference that we're talking about in the application level. So here both the applications are running. The first one is called the priority user finder. So here there is no use transition we have used. In this case we have used use transitions, but exactly the same application. Now let me start typing something over here. Let me try pick up any of the name and try to kind of do it. Maybe this one, Cormier, C-O-R-M-I-E-R. So I'll type C-O-R-M-I-E-R. Okay. I probably typed something wrong. Let's go and type maybe something a little bit simple, which is like hand. So H-A-N-D, hand, is matching. Now if I quickly try to remove it, if you see here, see 3-4 times I have pressed and that only it happened because on every keystroke the state change was happening, and because of that the computation was happening. So unless this computation was getting over, even my this state for the text box was not setting, right? Let's try this cole again to try and understand. C-O-L-E, cole happened very fast. Now I'm removing it fast. See, it's like taking a lot of time, at least 4-5 stroke that I'm giving as a user to cleaning drop, because React is holding the updates, both the updates together. Now with transition, I have separated out the update. This should happen without waiting for this one. So let's take this one, maybe king. So you have king. Now if I just remove fast also, see, there is no effect. It's getting removed immediately, but this particular state change happening separately. We have a loading also in this case, so that is kind of loading, in its own time. Let's do it again. Let's try to see king again. So I'll type very fast, king. Okay, I'll remove very fast. There is no problem in terms of this particular state changes, like what happened over here. If I take BATZ, bads, and try to remove it very fast, you'll see, yeah, see, 3-4 times I have to kind of press it. So I hope you understand like how to manage things better way with use transition. Please try to learn this hook, try to use this hook a lot. The time for the next and the last question of this video, and here we are going to understand Redux. So the question is, what is Redux? Explain this conceptual model with use cases, right? So Redux is about the global state management. When we discussed about context, we also discussed about there is something called Redux, and that's probably an alternative of context, but Redux is little more complex to at least perceive in the beginning, but underlying concept is pretty simple. We are going to see that. So when you're discussing Redux, there are a few points to keep in mind. One is like global state management. Then we have use state and use reducer. Then why you are talking about Redux at all for state management? We will understand Redux fundamentals, and then we will talk about Redux with a use case. All right. So let us just go over and try to understand this whole fundamental concept in more visual format, so that you won't forget this concept and you will be able to understand any Redux related questions with confidence. We have seen this slide before, isn't it? Like these yellow boxes are nothing but components, and these blue things are nothing but state, and we can also pass the props from one component to another component. So this is in the hierarchy, so passing props is not really a problem. We have also learned about context APIs, where if things are not in hierarchy, even in that case also, we should be able to pass some information. For example, I can create a context somewhere, and the same context I can pass in this hierarchy, I can pass in this hierarchy, where this hierarchy doesn't have any connection in between them. Again, this one is detached. Now, the context can be multiple in your application, but when you have to really store something which is like very centralized, like you have to manage all your application is too big, your application is really grown enough, and you really don't want to manage state in individual component level, and again want to kind of pass them as a props. your component numbers are growing, your application is growing. Rather, you want more predictability in your application, like who is changing the state, why a state is getting changed, how the state is getting changed. You want the entire trackability of these things. That's where you want to go for a global store concept. Okay, so let's talk about the global store. Let's talk about Redux. Before that, let's understand without Redux, how do we deal with a simple application. And please, one thing I want to note here, please note down the terminologies that we're going to talk about, because we are doing something very similar without Redux also. The same terminology when you use in Redux, it may sound a little complex, but the same thing we are using actually without Redux also. So here is a simple cart operation. You have a state called cart and set cart. You have two operations like add to cart, remove from cart. These are two actions. And then you have your JSX, where you show the cart number, how many items you have added into the cart. And then you actually call these two functions, these two actions from these two button click. Very simple. Now, one by one. First, this is state, we know. Second, this is action, like I'm updating the state is the action. Then this is the event handler that dispatch the action. Dispatching means sending, signaling, right? So it means that on click on button, I'm dispatching the action, right? So dispatch is another term. And then my view gets updated. So I have state, I have action, I have dispatch, and then my view gets updated. Now, if I see this one, I have state, I have action, and I have view. So a view, from a view, a user takes an action. The action update the state. Once the state updates, the view also gets updated, right? So this is the thing that already happening in your component. Now, next thing is like, let's talk about a use case of a store. Store in a sense is like maybe a shopping mall, right? So a store from where you buy thing, and say this is you, a customer, and you want to get something from this particular store, and there is a biller who is already sitting there, help you out with the checkout, right? So you add something to the cart from the store, maybe milk, groceries, or whatever it is. You go to the biller, request for a checkout because you want to pay and buy the things. What the biller does is basically provide the bill and help you with the checkout. And along with the checkout thing, what biller also doing, he is updating the inventory, he is updating the customer data, something he is going to update. This is a very simple application and it at this outlook, but there are multiple things to learn from this application. There are multiple things happening in this application. What are the state in this application if you have to count? Let me give you a few seconds. Okay, so let's talk about the states. The states are items, states are cache, states are customer. Okay, so this is the state that we are actually dealing with. The another state could be inventory also. What are the actions? Actions is like add or remove cart, create invoice, update customer data. Another action could be update inventory. So when we are dealing with an application, why we are showing this use case is like you have to clearly separate out what are your states, what are your actions, which action is going to deal with which state. Now, if we are going to do this in every component level or a component hierarchy level, at times you will be finding it very hard. Like, what is the relationship between these states? How these actions are modifying? Which action is modifying which state? Am I modifying one state and there is another state is related to it? So why that's get modifying? All these things you won't be able to track, or it is very difficult to track rather when the application really grows. On that point of time, you need more predictability. You need more better way of managing your states. Okay. So the problem is the state is managed in multiple ways. If there is a multiple component hierarchy, we are managing. The state gets updated from multiple places. Okay. So there is no traceability. There is no proper tracking of who update the state. It's very difficult, and the higher chance of polluting the state. So these are the problems that we have in hand, and there is no predictability. These are the problems we have. Now here comes Redux. How Redux solve the problem? Redux, first understand that it's an architectural concept. Without React also Redux exists. You can actually write a Redux code with plain old JavaScript. It's just an architectural concept. It has practically nothing to do with React. In React, as we are talking about more about state and managing the state, then Redux is a solution that comes in. There are many other solutions for state management other than Redux. Okay, so Redux is one architectural concept we are talking about. So how Redux? So we have a centralized store for state for the entire application. So it means any update happen, it's happening only in one place. There are no multiple places the updates happen. So first problem is solved, right? You know where exactly the update happens. You cannot make a mutable update to a state. A mutable update to a state means you have a state, in the state you have a value, you cannot directly mutate that one. You cannot go and directly mutate that one. As you are not able to mutate that one directly, it brings certain amount of predictability and the constraints like how this state can be mutated. So all updates done to the state is immutably. We'll see that. The UI, basically the component JSX part, dispatches something called action. We have seen that in the regular application, in the cart application also, the action was dispatched, which dispatches something called action and update the global store. The code logic that update the state, there is a code logic that update the state immutably is called reducer. So these terms, whatever is in oranges, store, state, dispatch, action, reducer, are the terms very famous with Redux. So you need to understand these terms. These are really not very difficult if you understand like how these things connects. Okay, so let's see the terminologies. Same thing that we just now discussed. So the terms are like dispatch, action, reducer, state, and store. I picked the term. So first thing is we have picked this term from here. Now we talk about there is a store or state basically gets stored in a store which is like centralized. Now the thing happened is your UI dispatch an action. Okay, the action gets dispatched. You have a reducer which is having the code to update the state. So it gets the current state. Okay, the current state it gets. It updates the state immutably. It reflects that update the state, and basically that updated state gets into your UI view. Okay, so this is how the entire Redux architecture gets in place. Okay, now let's take this example. Here is an example. There is a circle, there is a colored circle, and you have a bunch of buttons. If you click on these buttons, the color changes accordingly. If you click on orange, the orange changes. If you click on green, green changes. So this is your view. Now what happened? What could be the state for this application? Maybe the state for the application is as simple as color code. So that is the initial state, right? What kind of actions that you have? You have the actions of color change action, and you have this initial state. So it means that whenever I'm clicking on any of this button, this particular state change should happen. Now this state I'm keeping globally as a global store with the Redux architecture. That's what we're going to demonstrate over here. Now if I click on it, the action should happen. We told the action is nothing but something has to dispatch. So on the button on click, we can actually dispatch, saying that dispatch means I'm giving some signal like something has to happen. Now usually when we say dispatch, we actually dispatch an action. The action is usually a plain JavaScript object. It gets one thing called type, which says that what is this action about, and this name is whatever you want to give, which is something meaningful that somebody can understand. So it's like change the color is the action, and change the color to red, that is the payload. So action usually has a type and a payload. Type is what is this action about. Payload is basically what value I am going to send to my reducer so that I can change the state. Okay, reducer is the place where all the changes happen. So next thing is like taking this type and taking this payload. This is my reducer. If you see, this is a reducer, a simple JavaScript function which take the action and the state. Based on the action type, it's basically changing the state, and then it's returning the updated state. If you see over here, the state, exact state is not changing directly. We are actually creating a copy of it, of the state, and then on that copy, we are changing the color, and then we are returning the change state. We are not changing the state directly. That is what is like we told that immutably we will change. Now, once this change happen, basically, we have to kind of make the state updates. But for here, you are seeing that initial state we are getting it. We have action, and initial state we are changing it. This is what the change, where the change is happening immutably, and then finally it goes and update the view. It was black, we are changing it to red, so you have a red view. So you saw this, how in the Redux thing it is happening. Now the question might come is like, is it really worth doing all these things because it's a very simple application? The answer is no. If the application is as simple as this one, you don't have to really use Redux. But think about an application where the number of states are really, really huge. It has grown. Probably you are managing around 10 plus or 15 plus state management. And that is the time where you want to segregate in a way that your state manage globally in one place. You have meaningful actions and the meaningful reducer, so that when you debug, you know, like for which action which reducer is taking the call and how this particular state gets updated, right? So use Redux only when you have a large application state that is needed in many application places. Okay, the state updates very frequently. State update logic is complex. App code size is really growing higher. And finally, you think this is the right time to use Redux. So that's all about Redux, how it works. I hope that you understood the concept. You'll be able to explain to an interviewer. If it is the first time you are understanding this concept, I would suggest that you go back to the section again, read about it, whatever you read, try to write it, try to sketch it, like how this reducer actions and things like that work together. Practice it out a lot, so that is going to help you out. So that was the final question of today's video. I hope you understood it and you liked it. In the next part of the video, we are going to come up with more interesting questions and their answers, and we'll learn it much more better way. Okay, take care of yourself. See you soon. Was it useful to you? Did you learn something new? So the responsiveness of the app and global storage are the pretty awesome topics to understand. Please practice them. Up next, in the next part, we'll be talking about a few more special topics around styling, around error boundary, and all these things. So stay tuned to that, and please take a great care of yourself. I'll be back soon with another video. Thanks.